Right, Wayne, so Cat's Boys will be quite quick actually.
2 minutes, you reckon?
Yeah, you can go get it, can you?
Yeah, I'll get it in about then. Okay.
Alright, cool. So, circles.
Yes, that's chapter 6 of Core 1 from this book.
That book there, absolutely. And it's sort of like the first chapter, but with a different shape.
Yes. Now, as usual, you've done this at GCSE and we're going to take it a million steps further.
As A-level always does.
It does indeed. So, first, if I write up an equation, say x squared minus 2x plus y squared plus 4y plus 1 equals 0. What on earth does that mean?
Well, Wayne, first I can tell you that this is a circle equation. Sort of like two quadratic equations together.
Yes, so it's sort of like the x squared and the y squared is two parabolas.
Yeah, making a circle type thing. But like that, it's not very helpful to us at all.
No, so if we quickly draw up a circle, roughly what it's going to look like.
At the moment, we don't know.
No, we need it in a different format.
We do.
So first what we do is elbow the whiteboard.
Obviously. And the second thing is to factorise what we have.
Yes, both the x and the y factorise individually.
Yes.
So to factorise that is quite simple. You've done this before. It's the x minus 1 squared, because when you expand that it gets the x squared minus 2x.
Yep.
Then it would also give you a plus 1, so you minus.
If you want to get rid of that.
And then it's plus, factorising this y squared plus 4y is just y plus 2 squared. That would give you a plus 4, so you'd minus that as well.
And then we already have our plus 1 equals 0 at the end.
Now what you'd do is you'd put it x minus 1 squared plus y plus 2 squared and take all the other constants over to the other side.
Yeah, I'd probably make a number first.
Yeah,
so you
minus
get
1 minus 4 is minus 5.
Plus 1, that's 4. And then over the side it's positive 4.
Yep. And that is a lot more useful to us.
That is a lot more useful to us. So now we have a proper circle, but I don't know why it's useful, Wayne.
No. These are actually the coordinates for the centre, and this is actually the radius of the circle.
Squared.
Yes.
Obviously when you take things out of a bracket, they become the opposite sign they are inside, so that would become a 1.
And that would be the x coordinate of the centre of the circle.
So that can be here.
And it would be a minus 2 in the y direction.
It would.
So it would be down here. And when you put the two together, that's the centre of this circle.
Yep, and that's our centre point. What about a radius, Wayne?
Well, as Triv said, this is the radius squared, therefore the radius must be the square root of this, which is 2.
It is
That
2.
means it will touch the top here, because that's a distance of 2 up.
Absolutely.
And then you've just got a nice, neat circle around. Now, all circles take this form, and if I write that algebraically, I have wrote it up here, but I'll write it again anyway. You've got x minus a squared plus y minus b squared equals, and it's usually expressed as r squared, but that is the r squared. You square root it to get r.
Yeah, I mean to get out of the brackets, be positive a, positive b, and just r.
Yep.
Pretty jazzy.
It is, but it doesn't just make you draw circles.
It doesn't. It still has all the lines and stuff.
The kettle's probably been bored for about a minute now. I'll go
Oh,
there.
yeah, you go get that. So you also have your lines like you had before, and stuff going through things. But two words you might have encountered from GCSE. They are the normal and the tangent. The normal and the tangent are perpendicular to each other, and they do a lot of sort of things with circles. A tangent would be something like this, that go across the circle, and a normal would go something like this through the circle, making a right angle here. And often you have to work out the lengths between lines using Pythagoras, which is where our radius comes in really handy. Oh, Wayne's got the tea.
Yours was the Eeyore cup, wasn't it?
It was the Eeyore cup.
I've got a Trinity St Martin primary school cup. I'll close the door.
Oh, good plan.
Where did we get up to, by the way?
Just mentioned tangents and normals.
Ah, okay. So yes, they're perpendicular and stuff, as I'm sure Triv's mentioned. There's a third one that's sort of like both of these. We call it a chord.
Brang. Not like that. Not like that. It's one that sort of is in between the circle.
Yes. So it would do something like that, where it would have 2 points. That would be called a chord.
Yeah.
But how do you know if it's a chord, a tangent, or if it just doesn't touch it at all?
I remember something like that happening in the quadratics chapter.
Yeah, when a line intersects with a quadratic and then you use...
Something to do with northerns.
Yeah, northern... Well, you don't discriminate.
No, that's what it was the discriminant. Well, there you are. So you use that again with circles. But it might look a bit confusing.
Yes, it might have something, it might say something like y minus x equals 1 intersects with, say, this circle. Then you use what's called substitution, which we did a long time ago in chapter 1, I believe.
Did. And we put our x over the other side, perhaps.
So we know that y now equals 1 plus x.
And then we can put that in to where our y's are.
So what you'd actually get is x minus 1 squared, we'll use this bottom one, x minus 1 squared plus y, which is now 1 plus x, plus 2 squared equals 4. You'd have the 1 plus the 2 would equal 3, so it's actually in the bracket there will be 3 plus x squared. You expand all that, you'll get a neat little quadratic, and then you use the discriminant. If it has 2 real roots, it has 2 solutions.
Yep, again, that's above 0.
And you know the rest, because we've done it before.
You have any other questions, you can send them to us, and we'll do a particular one. We'll do something with that aimed at test yourself.
Yes, and there actually isn't a lot else to say about this stuff. You may need to use Pythagoras to work out lengths of lines.
Yes, but again, we've done over that sort of thing before, and sometimes you have to make a point a certain distance away from the circle. They might call it Q or something to be similar.
Once there's a point Q, work out its coordinates, or it might give you a length, say work out the coordinates, it might give you coordinates and say work out the length, and it will be something like that.
Yep, and you make a nice triangle. And it's quite simple really, so I think we're going to test yourself.
We'll do a test yourself now. I'll have my tea.
Question time.
Test yourself, question 4, page 107 from this book.
That book there.
Except for the first time, this is a 3-part question, we've added a part D.
We have, because it doesn't cover something we'd like to cover.
And that's the discriminant, which can get quite tricky sometimes, and we didn't explain it in the video because we thought we'd do it now.
Absolutely. So, let's crack on with it. If I read the question, you do the first part?
Okay, that sounds fair.
Alright, so it says, a circle has the equation x squared plus y squared plus 4x minus 14y plus 4 equals 0. Now, as with many circle questions, I often start with this. It says, find the radius of the circle and the coordinates of the centre.
Yeah, as James said, that's very, very typical. They nearly always start in the exact same way.
They do. And we just do what we did before. We factorise our x and y respectively.
Yes. So, I'll factorise the x first. You've got this plus 4 and the 1x.
Yeah.
Which is x plus 2 squared.
Squared. Then minus our 4, which would be the product of expanding that.
Then you do the same thing with the y. So
Yep.
we've got this y here and this 14, but it's a negative, be careful. Minus 7 squared.
And then we obviously minus 49.
Yep.
Plus 4 equals 0. Now I'd like our non-coefficient added constant to be on the other side.
Put a minus 4 and a plus 4.
They will cancel, just put minus 49 across the other side, making it just positive 49.
So what we end up with is x plus 2 squared plus y minus 7 squared equals plus 49.
And that's all we need to find our radius and our centre point. Our radius will be this square root of this.
Just for the sake of marking points, they might like to see you do root 49.
Yep, and then equals 7.
Just to prove you know what you're on about.
Yep, and then you take these things out of the brackets, so minus 2 and positive 7.
Would. Now, B, how about I'll read it, you do it?
Okay. Yeah.
Thank you. So, part B. It says sketch the circle, but careful, Triv. You don't just randomly do it, you've got to be ridiculously precise at A level.
Yeah, for a sketch it is quite precise. We need an axis.
We do. That's a very nice pair of axes.
Thank you.
It would probably want you to label this centre point, minus 2, 7, and get it in roughly the right place. So, if you put your minus 2 all the way over here, it would want your 7 to be all the way up here,
It would.
relative to it. So,
Quite relative. And also, something I'm quite pernickety with it is length of radius will show you if it will touch the axes or go through them, and they like that to be quite precise.
for example, this is 7 units up from the x-axis, and the radius is 7, so it should neatly touch this.
It should.
This
And
is
go
only
through.
2, but it goes 7 that way, so it should go past the x-axis and come back down. And it would want you to be quite a neat circle, like what Triv's done here.
Yeah.
It's best to do it in pencil in the exam, I would advise.
And I like you to label the radius as 7 as well.
Yeah.
And you could even use a compass. There's nothing wrong with a really precise circle.
It's just what they really need is the numbers. So if you can do a really lovely circle but without the numbers, no marks.
Yeah.
You could do an okay circle but with the numbers, full marks. But it's best to do both.
Okay, so stop again.
Yep, I'll do C.
Okay, so part C says find the length of a tangent from the point P, which is 6, 8,
6
to the circle. And this is when we go to our Pythagoras stuff we were talking about before. It's a little bit more tricky than chapter 1.
Again, it wouldn't hurt to put this on this same axis. It would be 6 across 8 up. It's going to be about there. Is 6, 8, this point P.
Mm-hmm.
It goes across and it touches the circle.
At a point we don't need to know where actually, which is quite handy.
Yes, because it shouldn't matter. It could also touch down here and should be the same length.
Yeah.
And we're working out the length of this line. Now, how on earth do you do that if you don't know where it touches the circle?
Well, this distance all the way around the circle will always be 7. Circles are symmetrical.
That's right.
And we can use Pythagoras to work out the rest of them.
So do you want to swap sides and I'll draw this circle up neat without all the maths around?
Yeah, okay, I was going to do that, but sure. Oh, you're welcome to draw a lovely circle. We can compare circles.
I'm not going to do it absolutely.
Oh, very nice.
We've got a point P up here, so it touches here. This length, as Triv said, is always going to be 7 units.
Yep.
We can work out this length
By doing sort of reverse Pythagoras what we did before. So we have another triangle, which you write in red.
Okay. We know, I'll just label this point is -2, 7. That's the centre of our circle we worked
It
out in
is.
part A. P is what, sorry?
6, 8, which we know.
Okay, so I'll do this part in red.
So you make another triangle and sort of use it from there. So you know the length of each of these sides. This one would be the difference between -2 and 6, which is 8.
And the height is going to be the difference between 7 and 8, which is just 1.
Then we use Pythagoras to work out what this thing is. So the 8 squared plus 1 squared equals our c squared, which you don't know yet.
So that's 64 plus 1. That's
Yep.
just c squared equals 65.
So c would equal root 65.
So this length here is root 65. But that's not the length we want. We want the length of the tangent to touching the circle. We want
We do.
that.
So then we sort of do reverse Pythagoras.
Yes, because this is the hypotenuse. So we'll call this question mark we're trying to find x.
Okay, so x squared plus 7 squared will equal 65.
Yep, so root 65 squared, which is 65.
It is.
So you got, then when you expand that out, x squared equals 65 minus 7 squared, which is 49. That's what
Yep.
7 squared is. So 65 minus 49,
Which is
21, 26, do you make it? No,
16.
16 I make it.
Yeah.
So that gives x equal to 4, which is good because that makes sense. If this is 7, you can see this is longer than that but shorter than that.
Yep.
So the length of this line up here
is 4, and
units.
that will be our distance from P to our circle. It does look a bit complicated. As long as you split it into a square or a rectangle, 2 triangles, it's quite simple. Now for our extra part D.
Yes, I'll read it to you because I've entirely made this up. Let's swap places.
Okay.
So part D, like we said, first time ever that we've done this, we've added a question because we feel we should cover it.
We should. So I'll write part D here. Okay, what am I doing?
Right, there's a line, and you want to write this down,
I
it's
do.
y minus x equals 1.
Alright.
And my question to you is, does that line intersect this circle, and if so, how many times?
Oh, well that's a pretty snazzy question. So, first, we want a quadratic, not a circle formula. So we need to substitute this into that. How am I going to do that way?
Well, the substitution method we spoke about way back in chapter 1. It would be easier to take the x over and then substitute y, and you could do it the other way around. You could say that x equals the negative y plus 1, but it's easier to just do y equals x plus 1.
Yep.
Where there's a y up here, it is an x plus 1. And when you expand that all out, it should all boil down to a neat little quadratic. So, we've got x squared plus, and now x plus 1 squared, Hopefully you're familiar with the substitution method. If not, check out our chapter 1.
Yeah.
Plus 4x minus 14 lots of this new x plus 1 plus 4 equals 0. Now this looks horrifically long, but it's quite simple mathematics.
Let's simplify it down, it's not too bad. So we have our x squared anyway.
Yep.
Then
when you expand out these brackets, you're going to get a
x squared
plus 2x
yep.
and then plus 1. You should get fairly fluent at expanding out quadratics and stuff. Then you've got a plus 4x minus 14x minus 14 plus 4
is
equals
quite
0.
long. And then again, simplify this down so it's less complicated.
We've got an x squared and an x squared there, that makes 2x squared.
It does.
Now the x's, you've got a plus 2x, a plus 4x and a minus 14x. So that's 6x minus 14x
Minus 8x.
minus 8x. Then just the numbers, you've got 1 minus 14 plus 4.
Which is just minus 9.
I make it minus 9 as well.
And that would equal 0.
So that's the line substituted into the circle. The next step is to use the discriminant, which we mentioned but didn't do, so that's why we're doing
so
this.
remember what the discriminant is, it's b squared minus 4ac. So what are the 3 things we're looking out for, Wayne?
Well, we're looking out for if it's greater than 0, equal to 0, or less than 0.
Yeah.
Greater than 0 means 2 points. Equal to 0 is just the 1, so it would be a neat tangent. And does not equal 0 is no real roots, it doesn't touch whatsoever.
Okay, so we put this in, so we have
8 squared, well, minus 8 squared, but it doesn't really matter.
64
Minus
4 times 2, which is 8.
Times minus 9, so it actually becomes positive.
Yep.
Doesn't so much matter what the numbers are now, you can tell it's going to be greater than 0, but it's going to be minus 4 times 2 is minus 8, times 9 is 72, and plus 72.
64 plus 72 is greater than 0.
136, I think, but
yeah,
it doesn't matter, it's greater
than 0, so that means it will hit through our circle at 2 points. And if you look at what y equals x plus 1, if you drew it on, you'd see that's right.
Yeah, it would look something like that. It will go through there and there. That's what it will look like. If you're really, really boss at drawing, you could probably do this just by drawing, but definitely do it mathematically.
Definitely do it mathematically. And once you've done that, then I ask you to work out what the points are.
And that's what we just did anyway, so we're not going to do a part E.
No. And that's our test yourself question.
Now, because there's only a few little points to mention plus a test yourself, the summary wouldn't be any bigger than this test yourself, so we're not going to bother with it.
So this will sort of be a huge summary of what we've done on total, and then go straight on to the next chapter.
Which is something about the rate
of changing something.